Hello, welcome back to another past paper question from a calculator paper. Let's go through this one. A boat sails from point A on a bearing of 0.45 degrees, 0.45 degrees for 12 kilometers. It then changes course and sails on a bearing of 120 degrees for 7 kilometers until it reaches point B. Calculate the distance from point A to point B. Give your answer, correct 3 significant figures. Okay, now we're going to do a bit of sketching, but this is not going to be the true size. This is not going to be an actual size thing. It's just for us to visualize so we can calculate things and see what we're dealing with and calculate things better, right? Visualization is the key. Okay, so we start from point A. A boat sails from point A on a bearing of 45 degrees. Now, bearing is always from the north of that point and it always goes clockwise. So if we say this is the north, now this is just a sketch, so it's not going to look perfect, but this is the north. So it sails 45 degrees. Let's say that's around 45 for 12 kilometers, right? So this is equivalent to 12 kilometers. It then changes course and sails on a bearing of 120 degrees for 7 kilometers until it reaches point B. So again, bearing is going to be from the north of this point. So if it's 120 degrees, let's say this is your 120 degrees. And it goes for 7 kilometers. It travels for 7 kilometers and then it reaches point B. This is what we need in order to visualize how we're going to calculate it. Then it says calculate the distance from point A to point B. So we are after this distance right here. From point A to point B. Now, what I'm hoping you can see, and the reason why we drew this image, was a triangle. Right? Now, this is not a right angle triangle, although my drawing is not the best, but it's not a right angle triangle. You never make an assumption it's a right angle triangle unless you're specifically told this or the image that's given to you gives you this or anything like that sort. But we're not going to make that assumption. But what we know is we need to find this length. We've got a triangle, we've got two of the lengths, and we need to use the sine or the cosine rule because it's not a right angle triangle. But in order to decide whether I'm going to use cosine or sine rule, I need to make a decision in terms of what I have and what I need. So I need this length. And I need some sort of angles in order to use a sine or cosine rule. Now, I need to look at, can I find either of these three angles? The only angle that I can find at this point would be this. We know this is the north. From the north to this point was 120. If I extend this like this, I'm hoping that you can see that is a straight line. So these two should add up to 180. So that means 180 minus 120, that is going to be 60 degrees. But that's not the full angle. So, however, there's one other angle I can find from this. Now, can you see that we've got the two norths of these 2 points? They're going to be two parallel lines, and they're being intersected by that line there. So that means that angle there and this angle here are going to be equal to one another because they're alternate angles. So if that's 45, then that is also going to be 45 degrees. So now I know the angle opposite the length that I'm looking for. Now, I cannot use the sine rule because I need a pair. What I mean by that is I need an angle with its opposite side, or I need a side with its corresponding angle, and I don't have the angle for either one of those. I have an angle opposite the length that I'm looking for, so that immediately tells me, because I have the other two lengths and the angle opposite the length that I'm looking for, the formula of the cosine rule is a squared is equal to b squared plus c squared minus 2bc cos angle. Right? Now this formula is given to you on your formula sheet, so you don't need to memorize it. It will be there for you. So now the most important thing for you to remember is that A is the length that you're trying to calculate, and that A, and cos A, the angle A, is the opposite angle, is the corresponding angle to that length, right? Right, so we're going to substitute all the values that we've got. So A squared is equal to 12 squared plus 7 squared minus 2 times 12 times 7 times cos 105, right? Put all of that into a calculator and a squared is going to give us 236.4815, and then if we square root the answer, we get 15.4 to 3 significant figures that was asked of us, 15.4 kilometers. Now, just one thing to make sure, I wrote this for the sake of demonstration, but as you're calculating this, use the answer button on your calculator. Don't round it up to anything because it can change a digit or two. So whatever answer you get, when you put this into your calculator, you're going to get a long number, then you're going to do square root answer. So the square root's the whole big number, right? And then the answer is 15.4, right? Hope that makes sense. Now let's look at the second part of the same question as well. It says, so that length there is equal to 15.4 kilometers. Now the second part says, find the bearing of point B from A. Now, right, so we always start from the north of the point, and it says from point B from A. We always start from where it says from this point, that's the point we start from. So we're starting from A, and we want to know the bearing from A to B. So that is the angle that we're after. Not a very good color, but I'm going to do it in black. That is the angle that we're after. That is the angle that we're after, that one in black. Now we know from the north to this orange line is 45 degrees. So now we basically need to find out what this angle is equal to and add the two of them together. Now, remember what I said before about the sine rule? If we have a matching angle and length, we can, and the opposite length of the angle that we're after, then we can use the sine rule. So here we're going to use the sine rule, right? So if I call this x, we're going to say sine x over the corresponding length is 7, the opposite length is 7, is equal to sine 105, which was the angle that we had for this, over the length which we calculated from the previous part, 15.4, right? So if we rearrange that, we're basically going to put this into your calculator, and then whatever answer you get, you're going to times that by 7, right? That gives you what sine x would be equal to, which is equal to 0.4391. Again, I'm just writing it for sake of demonstration. To do the next step, we're just going to use the answer button, right? Then we're going to do the inverse, which is we're going to press shift sine, and then that long number there. So use the answer button, and that should hopefully give you, so that will be sine to the power of -1 answer from the previous part. Now, if we round that up, it's equal to 26.0. Now, that is 26.0, and that angle there is 45, so we're going to add the two of them together, and that is going to give us 71 degrees. That is the angle there. So the bearing of B from A is 71 degrees. Hope that makes sense. Let me know if you've got any